I'll just open the ST micro. Okay, first I'll go for Google. Okay, I just type Nucleo STM32 F411 411. Okay, so and open the ST microelectronics website. Okay, so you'll get this page, STM32 Nucleo 64 development boards with STM32 F411RE. Okay, you have to, in this board, like you have the CAD resources where you could download the bill of materials, schematics, and the user manuals. Okay, documentation part, you can download the user manuals, presentations, okay, and flyers, product certifications, and everything. And then you have an option called tools and software where you could download these softwares. Okay, boards, development tools, and STM32 Cube 4. Okay, so STM32 Cube MCU package for this low layer APIs and CMSIS. Okay, click this one and you download the, you click this STM32 Cube F4. Okay, and then you click get. There are two options to get from GitHub and get latest. Okay, choose this get latest, click accept. Okay, it will ask for you have to log in. It's free. Create an account. You just log into the account. Okay, okay, so I have just logged into my account. So the file size will be 2 GB. It will take some time, but I have, usually it takes some time to download the software. Okay, you download the latest, click start download. So once the download is done, you just open this file. Okay, so you have drivers here. Inside drivers, you have BSP, CMSIS, core, include. Okay, so you have include, and inside core, you have again include. Okay, and device, inside device, you have STM32 where you have the include folder here. Okay, so you copy this. I'm going to copy this. Okay, right click and make a copy. And delete the documentation part. In drivers, like I just copy the include folder. Okay, this include folder. So core include. Okay, same as this include and this core include are same. So I am going to delete the core A and delete core A. Okay. So I'll delete this include also, delete, okay, device, include. Okay, so I just copy this folder, CMSIS. Okay, just copy this folder. I just create a folder called day 15, sorry, day 25 demo. I paste this folder here. Okay, create a folder called target. Okay, and I just open STM32 Cube IDE. Okay, once I create the project, I have to link this files. Okay, so this folder has the device specific header files. Like we are using STM32 UART REH. Okay, so this is the device specific header file which has the registers. Okay, so we can use which has all the registers. We can use this registers and definitions. Writing the code. I'll show you the example. You could also write the code. You could also write this file. Okay. We have already previously in previous experiments we have done this experiment. So you could download this header file from the ST website and you can include. I'll show you how to include that. Go for file. Go for new STM32 project. Click X. Once a file is created, like okay, so close this one. Click board selector. Choose the Nucleo board F411RE. Choose this board. Click next. Example 1. Click empty and click finish. Okay. So in the source file, you just include first, I'll increase the font size, preferences, general, appearance, colors and fonts, C++, editor. Okay, I just increase the font size. Okay. STM32 F4 XX, okay, .h, XX.h, sorry. It is a user defined file, so you have to include on double quotes. Okay, save the program, right click, build the project. So there is no such file, okay, no such file or directory. You have to include this file. In order to include this file, you right click, go for properties, C++ build, okay, choose C++, click settings and go for the compiler, include paths. Okay, in include paths you click and you have to copy the input path. So I have stored the day 55 demo, okay, hash include. I just copy this path and I paste it here, click OK, click one more, and again you have to include this file also, device CMS code, include. Okay, copy this and just paste it. Okay, we have included the paths now. Click apply, click apply and close. Okay, right click, build the project now. Okay, so again we have got an error, so this error definitely you will get. Okay, So once you include this file, definitely so the error is, please select first the target STM32 F4X device used in your application, okay, which is in the file. So you choose this one, okay, right click, go for open declaration, okay, you search for STM32 F4 STM411, okay, so this is the one. You have to copy this, you have to copy the symbol. I click, go for properties, okay, and click preprocessor, and you have to include this, you have to include the symbol, okay, have to include the symbol. Click apply and close, okay. Now try to rebuild this one. So there is no error now. So the header files are configured correctly now, okay. So now you can use the header files. So the header files which we download from the ST website, okay. So these are all the header files, okay. So if you want to view this file, here it is. Okay, so this is the file. So you could make use of all this structure. Okay, let me check for GPIOA. Okay, so it has all the address. They have defined all the peripheral address here. All the memory map has been already defined. So you could reuse this one. Okay. Before that, you have to go like all the registers like GPIO base peripherals. Okay, you have to go through the header file once thoroughly, like GPIOA. Okay, has different GPIOA and the type def struct of what are all the registers of there, and what are all the member elements. Okay, you can go through the member elements. So definitions. Okay. These are all the member elements, CRC, ADC, okay. So struct.com, ADC, CRC, and this is flash GPIO. Here it is member elements, mode or register, type or PUPD or ID or OD or BSSR or, okay, AFR. So all these are member elements. Okay, so I'm going to use this member elements, and we are going to write this UART programming for both transmit and receive. So I'm going to copy the file. Let me open a file from the previous project, from the yesterday project. This PC desktop. Okay. So day 24 demo. I think it's day 24. So I just use a file from this project main.c. Okay, so this is the file which we have written yesterday. Okay, so this is the file. I just drag and drop this file. Drag and drop, close this one. Okay, file. Okay, just drag and drop to change. Okay, so I have changed this one, change this format. So here I'm going to write the code. Okay, by going through this code, I'm going to write the code for I'm going to use the member elements inside this header file, and I'm going to write the code. So you could also do the same thing. Okay, so first let's start with hash define. So I just copy all this. I copy all this and just paste it here. Okay, so sys frequency and clock baud rate. Okay, so here, okay, baud rate, everything, let us copy here. So no need to use this, no need to use the structure panel. So I'll also copy the functions. I'll copy the functions. You want write tx init, okay. I'll just copy the functions. Okay. Okay, so I'll close this one. Now let us write the code for this. Okay. So enable this GPIO. So instead of this, I just comment this line. So instead of this, I'm going to use the RCC register. So the member element is AHB1ENR. It will be in the same name. Okay, so that you could use the same name. If you want, you could cross check like GPIOAEN. Okay. And for this, like I'm just commenting this line. Okay, and I'm writing the alternative lines GPIOA. So you have to access the member elements mode on. Okay, paste it here. I just copy and I paste it here. Okay. And for alternative functions, okay, for alternative functions, I just comment this line. The member element is declared as an array there, like GPIO. Okay, AF4. Copy this, paste this. Okay. Just copy this. You have to set the appropriate bit by going through the data sheet. So this is for setting the alternate function type. Okay, for setting the alternate function type. And for this, comment this line. So this will be on the RCC register, RCC APB1ENR. Okay. Sorry. Okay. So for this line, you have to use USART2 check for BRR. Okay. The rest is same. You can copy this and you can paste it here. Okay, for getting the BRR result. So this CR1, like USART set baud rate, I'm going to declare the CR1 transmit enable. This is for transmit enable, okay, and for USART enable. This is for transmit enable and this is for USART enable. So I'm going to declare hash define control registers hash def CR1 underscore T. Three, it means 8. Okay, 8. We have used 8 here, like 8. So this third bit, we have to shift for 4 times 0, 1, 2, 3. Okay, so it will be 8. This is for transmit enable and this is for the UART enable. Okay, first we will go with the transmit and then we will come for the receiving enable. Okay, TXE transmit enable. Okay, and this is 7. Okay, so let's configure this one. Have configured till BRR. Okay, so copy this user to copy this, access the member element is CR1. Okay, we have to CR1 underscore T 8. Okay, this is USART enable. Okay, so we have completed. Let us check for the UART write is also there. So here we need to add this one. So UART USART to okay, and it should be and of SR underscore TXC. Okay, DR. Okay, so we have completed this one. Okay, so we have completed the baud rate. Okay, so let me check whether it is working or not. So UART write, let us call this function UART write here. Of A. Okay, so right click, build the project, right click, build the project. Let me check for error. We have 2 errors. Okay, so compile the project. So right click, run as STM32 Cortex application. Okay, click OK. I'll open this real-term serial monitor. So it should print A, okay, port of 6. Okay, it's one. The baud rate is 9600. So I'll take this while, simple while of 1. And build the project. Okay, so it is 9600. The baud rate is 9600. So I choose 9600. Click open. Okay, click open and check for the so we cannot initialize this UART. Okay, so I just copy this code, just initialize the code, build the project, right click, run as STM32 application. Okay, and let me check on this real term. Okay, so now we are getting the data now. So I will modify the code for the receiver also. So before that, I will add a simple code for printf. I just go for syscalls.c and I copy this function. Okay, I just copy this function. Okay, and I add a simple code. ch. Okay, UART2 underscore right of ch. Okay, ch. So I just write the simple code and I use printf here. Printf of hello world, hello. Okay, /n/out. Let me check. Build the project. Right click and run as STM32 application. Okay, program is getting downloaded inside the board. Okay, so we are getting hello now. Let us write the code for the receiving. Okay, receiving how to for receiving pin. Okay, so transmit enable, you need to put receive enable here, CR1 RE. You have to enable the receiving. Okay, receiving pin is the second, and SR TXC you have to put SR receiving enable RXNE. Okay, it's 5. So you can get this value from the data sheets. Okay, so here like we have declared as port 2 PA2. Now we have to declare PA3. PA3 is for the receiving pin, PA2 is for the transmitting pin. Okay, so we have to configure PA3. First we have to enable this PA3. So to enable this PA3, I just copy this GPIO, and here I need to change the value as this is 4 5, so it should be 6 and 7. Okay, 6 and 7. So this is for PA3. Similarly, I need to copy this AFR, and for PA3 I have to configure for PA3. So 11, it's 12, it's 13. Okay, because it's adjacent pin. So 15. Okay, and you have to enable the transmitting as on the USART2 register, control register. You have to enable the transmitting, as well as you have to enable the receiving. Okay, RE. We have already configured RE. Okay. Now we have created this one, so we need to create UART read. Okay, UART2 read. So I just change this function to read. So here I should be it should return a value char and it's empty. It's void. Okay. Here it's yes sir. It should check RxNE. Make sure the data register is not empty. RxNE. Okay, this is transmitter. Receive data register. Okay, you just return this value. That's all. You just return the data register. So we have completed the code for UART read. Okay, so let me call this function. First, let me declare this function on the top. Okay, so here let us call this function. Okay, so UART read. So I'm going to char of key. Okay, so key equal to UART read if key equals 1. Okay, if I'm pressing 1, else if key equals 2. Okay, else okay. This is 1 is pressed. Okay, printf 2 is pressed. Okay, key is pressed, some key is pressed. Okay, let me compile the program. Right click, go for debug, run as STM32 application. Okay, so the baud rate is 9600. So I will close this. I will open this Arduino serial monitor. Okay, the COM port is 6. You could get those details from the device manager. Go for tools, choose the COM port is 6, already choose serial monitor. Okay, serial monitor. I click 1. Okay, the baud rate should be 9600. Okay, 1 is pressed, 2 is pressed. Okay, so we are getting if else statement like else if. Okay, so I just remove this one, else. Okay, let us check for this. build the project and run as STM32. Okay. Okay, let us try else if key equals 2. Okay, 2 is pressed, else let me leave it empty. Right click, build the project. Okay. Okay, I give send, 1 is pressed. I send 4, nothing is happened. 2 is pressed. Okay. So it's working. So you could have your own logic. 4, okay, nothing's happened when I send 5. When I send 1, it's 1 is pressed. Okay. So I just explain you the code one more time. So we have used the same code like the previous logic, except like we have used the inbuilt header file, and we have called this structure and member elements. Okay, we have called the structure and member elements. You just go through the header file. Okay, you click this file, right click, open declaration, and just go through the header file, like what are all the structures are there and what are all the member elements. Okay. So if you check STM32 F11x 411xc.h, okay, so you could find out the structures and all the member elements here for real-time clock. This is for RCC register, like BDC, like APP1 RSTR, APP1 ENR. Okay, so you find the structure RCC, and these are all the member elements. Okay, so you could use this one. I2C, these are all the member elements. SP. So the rest of the code, the rest of the 5 days, I'm going to use the same header file. So you download the header file and include it in the project, and repeat the same code. It should work on your end, so that you will be familiar of how to use this, header files. Okay. Header files. So thank you so much for your time.